Good afternoon and welcome to this lunchtime's session looking at hearing loops, what they are, how they work, and how you might go about specifying them, and some of the things you need to be aware of. We are recording this, so it will be available to you and colleagues afterwards, and we'll round up with a Q&A if you've got anything. But before that, we will go through what a hearing loop is and how they work, and then talk about hearing loops on public transport, which is why you're here and what you're interested in. Some of the challenges with buses, how you might go about testing hearing loops, given that it's not necessarily obvious whether they're working or not. And then, as I say, wrap up with Q&A. So why are hearing loops important, particularly in the sort of lighter transport? So at the moment, about just over 15% of the population of the UK has some form of hearing impairment. A lot of those are significant enough to need the use of a hearing aid. And the latest estimates are that by 2035, so only 10 years' time, that will have increased to 20% of the population will have some form of hearing loss significant enough to need some support. And at the moment, we believe that something around 12% of passengers have a hearing loss. That is a rail figure. I suspect it will be higher for bus users. So what is a hearing loop? A definition for you. A hearing loop or induction loop system, as they're often called, or a T-loop system. It's an assistive listening technology that helps people with hearing aids or cochlear implants hear more clearly in noisy environments. So that is supporting people that need some help because they have a hearing problem that means that they can't hear as well as they perhaps might do, as well as those that have no hearing at all and can be supported by a cochlear implant. There are not many components needed to create a hearing loop. You have a microphone or a sound source. It doesn't have to be a microphone. You could plug it into your telly or video or whatever. You've then got a hearing loop amplifier, a bit like an amplifier for speakers. Not very dissimilar at all. And then you have a loop of wire that runs around the space that you're wanting to provide the information in, and then the person that's receiving the audio has a hearing aid of some sort. We typically think of hearing loops in meeting rooms and conference rooms and things like that, where you've got one or more loops around the edge of the building, and you've got somebody up front presenting, and you've got lots of people listening in through a PA system. And if you've got a hearing loop and a hearing aid, then you're picking it up from the hearing loop. To be able to hear a hearing loop, you need to have a hearing aid with a T switch on. Now, not all hearing aids do. The basic NHS hearing aids, for example, in the UK don't, because when you have a little bit of hearing loss, enough to need a hearing aid, but not of significant hearing loss, a microphone works okay. As your hearing loss increases, the need for additional support in some circumstances means that that's when the T switch is added. It's really quite a widespread thing in the UK to have a hearing loop. In Scandinavia and Europe and now Australia, it's also pretty widespread. You will regularly see T-switch signs, and in the US, adoption is beginning to take off, with a number of states mandating its use in public service, for example. So, as I say, it's beginning to grow in the US as well, as Europe. So the reason for having the T-switch is that a hearing aid, the way it works, it's just a microphone and a little amplifier that goes into your ear, and so the microphone's picking up sound from all over the place and amplifying that, and that's not necessarily from the person that you're wanting to listen to, particularly in a big auditoria, with a bit of murmuring and shuffling around and things like that going on. Hearing aid users going to hear that really quite strongly, and potentially not the person that they're needing to hear from. And so the T-switch just enables you to not mute but cut down and bypass a lot of the background noise, and just get what they're needing to hear from, which is why it's also used in other environments where there's a lot of noise going on and things like that. So the loop works by the person or the source of what you're wanting to listen to being amplified around the induction loop. It's just circulating the audio around that loop. In the hearing aid, you've got a coil that's picking up that that audio that's going around the loop, which is just creating a magnetic field in the middle of it, and the loop within the hearing aid picks it up, a bit like an isolating transformer, and then that feeds it into the amplifier in the hearing aid and then into the ear. So really quite a simple concept. Because of the way that the induction loop, the hearing loop works, you have to be pretty much within the middle of the loop for it to work. You do get a bit of cascade outside of the loop, but not very much. And with a little bit of careful tweaking, you can have multiple induction loops in the same room without crossover. So you can manage it quite tightly, as well as systems that are very directed at one person. Whoever's presenting, for example, whoever it is that you're wanting to talk to at a counter. You can get systems that will enable people to talk in a more interactive way without needing to have a microphone in front of their mouth, because you can put microphones around the room. The systems that manage that need to be really quite intelligent to make sure that you're not also amplifying lots of background noise and shuffling and things like that. So it's very attuned to voices and being able to direct that. So some of the benefits of hearing loops for people that are using them, it does, as I said, reduce that background noise. It means that it's very easy for you to be able to concentrate on what the system is trying to direct you to. You know, somebody presenting, somebody talking to you at a counter, that sort of thing. And it enables participation in big groups and spaces, you know, meeting rooms, churches, theatres, in a way that otherwise would be really quite difficult and distracting for somebody that's got a hearing aid. Because it's reasonably ubiquitous, you don't need additional devices. In the past, in some theatres, for example, you've had to, if you need audio support, you've had to pick up a little infrared receiver and put headphones on. And there's a transmitter at the front of the theatre, for example. With a hearing loop, you don't need to worry about that. You just switch your hearing aid to T, and away you go. And as I say, most modern hearing aids have a T switch if they're designed for people with a with a reasonable level of hearing loss. So they're used in all sorts of places, not just bigger halls and locations, but also customer service desks, you know, ticket counters at train stations and airports and things like that. You'll often see a little hearing aid sign with a T on it, which symbolises that it's got a hearing loop, and that particular counter will have a small hearing loop directed at where the customer's going to be standing, and you'll see a gooseneck microphone or something similar for the person doing the serving to talk into. Hearing loops matter because it's really quite easy for somebody with a hearing impairment to become quite isolated and not be able to take part in a lot of the more social situations with large numbers of people, and because it's pretty ubiquitous, that means you don't need to have lots of expensive dedicated equipment and things like that. And it's not vastly expensive to install, so there's little excuse to not have it fitted as standard, particularly in new builds or when you're doing refurbishments of buildings and things like that. And we'll come on to transport in a minute. So there are some quality standards for hearing loops that when you're specifying, when you're thinking about buying a hearing loop, you need to ideally make sure are being followed. So there's a British standard for a code of practice for hearing loop systems, which goes through things like signage and where you should be using them, some of the good practice about making sure cables don't get damaged and things like that. And then there's an IEC standard which details the performance standard for hearing loops and is much more technical and goes into field strength inside loops and heights for measurement and things like that. So there are two things that you should be including in specifications, the code of practice and the performance standards. And you need to make sure that whoever is doing the design, particularly where it's not a simple wrap a bit of wire around a building, as in the case of public transport, be it trains or buses, you need somebody that knows what they're doing to design the system to meet those requirements. And then really importantly, you need to test that the implemented system actually meets the requirements and is tuned rather than just installed and they walk away, because you do need to make sure it's tested, and we've got a bit on testing in a bit. So on public transport, hearing loops are quite widespread on the railway, particularly because the Department of Transport has its design standards for railway stations that have specific parts for accessibility, and that specifies that wherever there's recorded information, for example, PA systems, help points, customer service points, should be equipped with an induction loop. And there's other parts which I probably should have referenced here that talk about live rather than just recorded information. So it is a requirement that hearing loops are installed in railway stations, and also you'll start to see more and more trains having it on board for the audio announcements as new rolling stock comes in, because it's only been mandated there for about 10 years or something. On buses, until very recently, until the accessible information regulations in 2023, there was no requirement to have hearing loops, but new vehicles now have to have a hearing loop fitted that provides the information that's coming over the PA system for next stop information. Now the regulations, as a number of other events that we've run as RTIG and CPT have run and the DFT have run, gone to explain, the requirement is to cover the priority seating area and the wheelchair space, so that somebody in those areas, if they're using hearing aid, can hear hear what's being said. The regulations are being phased in, so new vehicles and vehicles that are 5 years old now should, if they're meeting the regulations, have a hearing loop installed. Vehicles up to 10 years old have got until October this year to be fitted, and the older vehicles have got until 2026 to be fitted. So over the last couple of years, there's been a lot of activity on buses with people fitting hearing loops. Some installs are better than others, of course, but they are needing to cover the wheelchair and priority seating areas. Whilst it's not mandated, it's a good idea if you can to provide wider coverage. Hearing impairment is an invisible disability. It's not like somebody in a wheelchair or needing a stick or clearly having some form of disability. So a lot of people, if it's just a hearing impairment they've got, will sit wherever they want, and they're free to do that, and they find it awkward to sit in a priority seat, for example, because unfortunately there's sometimes be challenge about why you're sitting there, and the pressure if somebody with a physical disability gets on. So if you can cover the full footprint of the vehicle rather than just wheelchair and priority seating areas, and for some vehicles it's actually easier to do that than restrict it to the minimum requirement. And the other thing to think about is the driver, boarding, passenger area. And if somebody needs to talk to the driver, how they can interact without that conversation being broadcast to the whole vehicle. It's possible, and some operators have installed a separate loop into that sort of vestibule cab space to enable boarding passengers to communicate with the driver using a hearing loop. So there's a number of challenges with buses in particular with hearing loops. Because the hearing loop works on a magnetic field. A bus has a lot of metal in and around the chassis and bodywork, and so that causes problems. It means that the coverage of a hearing loop is a little bit unpredictable depending on where the walls are and seats are and things like that. For a hearing loop to work properly, if you've got a lot of metal relative to the overall area of the loop, then you need to handle that quite carefully. And so vehicle specific hearing loop amplifiers often have a special bit of circuitry that you can turn on and off to cope with metal. So that's something to make sure that you've got when you're buying hearing loop amplifiers. The installation of the loop needs to be done quite carefully to avoid interference from other electrical systems. It's more the heavy electrical systems that seem to be causing challenges rather than CCTV cameras and displays and things like that. Things like regenerative braking in particular seem to cause a lot of low frequency interference, which hearing loops will pick up on as a buzz. The frequency of which varies depending on the speed of the vehicle, for example. Same with hybrid vehicles, they seem particularly susceptible. Pure electrics seem to be a bit better, so yeah, anything with changing heavy electrical currents seem to be a bit of a problem. So needs some careful design to make sure that you haven't got interference. A lot of the early installations in London, for example, technically were fine, but actually if you tried to use them as a hearing aid user, all you would just get is buzz when vehicles were braking, for example. Buses don't have a lot of space, and it's not always very easy to get access to retrofit cabling, and so the implementation needs to carefully think about which panels need access to, and that's why more often than not the loop is actually installed at roof height rather than at floor level, because it's easier to get to the coving areas and things like that. Each individual vehicle design needs some tweaking because of different layouts of seats and access panels and where components are. So it's not just as simple as going, well, we're just going to install them all in the same way. You need to have a plan for the type of vehicle and where's best to install it. We'll come on to testing and that sort of thing in a little bit, because testing will help you refine the designs and things like that. Fortunately now, with a lot of buses having been fitted, the larger manufacturers have got pretty good method statements for most types of vehicle now. Vehicles aren't flat like a nice meeting room or a conference hall. They're raked, and so if you've installed your loop at ceiling height, seats down at the bottom that are in the wheelchair and priority seating area, they're going to be flat on the flat boarding level. But as you get further towards the rear of the vehicle, quite often the seats are raised over the wheels and things like that. And so in those seats further back, if you are providing full floor plate coverage for a hearing loop, the passengers' ears are going to be much closer to the center of the loop than those in the priority seating area, and so therefore likely to be receiving stronger signals, and therefore needing to reduce the volume of hearing aids and things like that. And so you need to be doing testing on a number of the seats around the vehicle to get the overall power and volume of the loop right, so that it works for everybody but doesn't blast people's ears too much. And seats in the middle of the vehicle and things like that often are not well served, because you will install hearing loops in the coving area of a vehicle if you're retrofitting in particular. So you can't do the back seats and you can't do the middle seats, and so coverage will and signal strength will be dependent on where you're sitting in the vehicle. Fitting cables is really awkward, particularly trying to find spaces where there aren't lots of other electrical cables that are going to interfere or you're going to get in the way of, and are going to need access to for maintenance, because you don't want people disturbing and breaking hearing loop cables when they're going in, replacing a light cable or a light fitting or something like that. So it is quite difficult on most vehicles to get the cabling installed nice and neatly and away from place. But once you have, you then need to make sure that what you've installed is tested and working properly. Some of the fancier hearing loop amplifiers allow for remote control and monitoring through web pages, SNMP traps and things like that. So if you've got a vehicle network, you might be able to remotely monitor whether the system is working or not. What that tells you, though, is just that the system thinks it's working. The amplifier is connected to some cables and it's sending out a signal. It doesn't tell you whether people within that loop are receiving information at the right level or not, or whether it's intelligible. And so there are a number of different testing units available. You can get plug-in devices that will plug into your mobile phone. If you've still got a jack socket on your phone, and act as a hearing aid with a T switch on, and do measurements to check that the strength of the magnetic field's right. You can get dedicated testing devices that do that. They're of course a bit more expensive, but if you're doing a lot, it's well worth that investment because they're not desperately expensive. And those you can also then plug in headphones into, so you can actually hear what's coming out through the hearing loop, not just technically, is it working? Actually, is it intelligible? Because as I say, you can often get interference from other electrical devices. So technically it might work, but actually it might be unintelligible if you've got a lot of interference. And then at the more subjective end, you can get portable headphone units, a bit like an old school Walkman. You plug your headphones in and it's acting like a hearing aid with a T-switch. Or you might have somebody with a hearing aid and a T-switch, of course, to be able to hear what's going on. But if you're doing installations, it's well worth investing in one of the proper testing units, because they're really easy to use and they're not desperately expensive. So to meet the IEC testing requirements, you should be testing when people are seated and when they're standing. So when they're seated is about 1.2 meters above the floor typically. When somebody's standing, about 1.7. And so you need to test at those. And on a vehicle, you should be testing at different points as around the floor plate of the vehicle, to make sure that when somebody's standing, for example, towards the back of the bus, they're not being, they're not receiving too much sound, and when somebody's sitting down at the bottom, they're not barely hearing things. And so you need to do that testing when you're doing your initial method statements and things like that. You just put a bit of loop a bit of cable with a bit of tape on in a temporary installation to just play with where the cables should be and things like that, and then test in as many seats as you can. Of course, once you've done it on your sample vehicle, on in production installations, you don't need to do as much testing. You just need to do a bit of spot testing to make sure that there's nothing odd about that particular vehicle. It's not just initial testing you need to worry about. And anyway, initial testing shouldn't just be done when the vehicle is stationary in the garage. Test it when it's in representative motion for the routes it's going to be run on. If you're running a bus service in Norfolk, you probably don't need to be running it up and down lots of hills. But if you're if you're in West Yorkshire or Sheffield, for example, a lot of hills, vehicles are going to be putting in a lot of effort going up, and there'll be a lot of regen braking on the way down. So test while it's in real world sort of situations to make sure you're not getting interference. And in the same way that we recommend engaging user groups, some of the most operators have got some form of user groups with good representative of disabilities and impairments. Engage them like you would when you're doing a audio-visual implementation project. Make sure you've got some people that have got T-switches and get them engaged, because the timing of audio and things like that might need to be tweaked and things like that, depending on gaps between stops and things like that. So get them involved, because actually then they'll start to realize that you've got these facilities on bus, particularly during the phased implementation based on age of vehicle, and it keeps them on side. Because hearing loops are sort of invisible, you need to be making sure that you're putting in place ongoing regular checks, both from a technical perspective, so amplifiers that have got remote monitoring, or little LEDs that tell you whether it thinks things are working. That tells you to a degree that actually it's not technically broken, but it doesn't tell you whether you've suddenly got lots of interference or something like that because you've had a new alternator fitted or that sometimes causes problems. So you need to be testing on a pretty regular basis with something that enables you to actually hear what's coming through and whether it's being interfered with. So those that are applying for audiovisual grants, we're recommending that as part of the hearing loop installation, they're also being provided with one of the headphone amplifier things, just so that they can carry on making sure that things are working on a regular basis as part of the 28-day checks or something like that. So that's a quick run through of things to think about and make sure that you're doing once you've got hearing loops installed. If you want to know more and understand more, the RNID has got some good useful practical information on their site. On a more technical perspective, two of the big suppliers of systems in the UK, Ampetronic and Ardent, they've got a good amount of information generally about hearing loops and how they work technically, as well as their specific product stuff. And links to their pages are there. Okay, so hopefully you found that useful. I don't know whether you've got any questions. No. Okay, a couple of adverts in 3 weeks' time in Birmingham on the 11th of February. We've got an event on franchising, looking at some of the different approaches to franchising and the implications for data. So we've got Manchester, we've got Transport for West Midlands, we've got New Zealand, we're hoping for Singapore, and we've got some European experiences coming along, so some interesting things there. And then a bit further afield, middle of March, improving operational management of buses, control rooms, disruption information, that sort of thing, and that'll be in London. So see you at one of those, hopefully. And if you didn't know how to get hold of Artig, then contact details are on the screen. Thank you for watching this Artig webinar. To find out more about Artig and our work, then please visit our website at rtig.org.uk. Thank you.